I'm going to do a quick example of how to create a quick energy model based on the dimensions that were entered in the example given, just for fun, using Autodesk Insight. So we can type a location, we can pick a weather station, one starting with 59 are actual weather stations, typically at an airport. Now I'm going to create a massing, which is the easiest way to create an energy model, rather than using more complicated Revit elements like walls, doors, and roofs. So the example given was 30 by 80. I'm going to turn this into a 3D object and make it 20 feet tall. And then the Revit workflow requires mass floors to be assigned to this mass element, which identifies it as being a conditioned space that needs to be calculated. Otherwise, it might be a shade surface for an adjacent building. So notice how we have an analytical floor plate that's 2,400 square feet. The next thing I'm going to do is go into the energy settings dialog box, and I'm going to enter our 20% window to wall ratio. We'll have different options once this gets pushed out to Insight, but I'm going to pick an HVAC system. Notice the building type is set to office. I'm also going to enter some specific envelope settings. So U equals 0.4. So there's a few options here. We'll just do this small double glazed low E coating. Exterior walls, you can see there's going to be a lot of walls that match what you see in ASHRAE 90.1. When you get to this section, R13.3 or R13 plus R7.5 continuous wood frame. But in this case, I'm going to type U equals 0.02. And here's an R38 wood frame wall. Of course, it doesn't list that here, but this also has a thermal mass associated with it, and it's been properly derated. And then the roof is U 0.018. U equals. So there's one option in there. Wood framed. So now we've defined the envelope. I'm also going to adjust the perimeter zone. So ASHRAE 90.1 Appendix G has a 15-foot perimeter zone, so we can get thermal perimeter and core thermal zoning. But I'm going to change this to 12 since our building's 30 feet wide. 15 would make it so that that doesn't show up, but I just want to show that it does actually show up. And then a quick additional example is that if we wanted to add sunshades, we can actually model them, and that will be taken into consideration. So maybe we have 2'6", and then I'm going to select this thing and give it a thickness. If we go to the elevation, I'm just going to move that up some arbitrary amount at the moment. And then I'll copy that up so we have another one. So on the west side of the building, there's some sunshades. And then on the Manage tab, MEP Settings, we can see the internal loads for the specific occupancy type. So this is coming out of Ecotech, something that Autodesk bought many moons ago, and so some of this is a little dated, like pre-LED light power density. So we can adjust that. We can also specify the schedules for occupancy, lighting, power, all of these other things. And then once we create the energy analysis model, so I'll click create energy model. We have this 3D view that has the perimeter, 12-foot deep perimeter, and the remaining core zone. The actual required loads are listed here based on the schedule and people loads and all of that. We can also then duplicate this view and create an analytical surfaces view. Wish it made one of these automatically, but it doesn't. You can add one of these to your Revit template easy enough. So I'm just going to change this setting so that we see the analytical surfaces rather than the analytical spaces. So remember, this wall was R38, but the actual R value and thermal mass are listed up here. There's also the sunshade, which is a shade surface. There's the glass, which is the U.4 that we specified. There's the roof, the R52. And now we're ready to push this out to the cloud, but actually I need to save my file first. Once the energy analysis is done in the cloud, there's a couple of quick adjustments to set it to metric and show us EUI. It's defaulting to cost, and it gets the utility rates, which is just generic numbers for gas and electric, from the local or some sort of national utility database. And then if we switch this to a row and show the EUI mean, ASHRAE 90.1 2010 is what this is hardwired to. It has a connection to the Architecture 2030 zero tool, so that would be the zero tool number. And the square footage just as a double check. And so 129 obviously is high, but that's the mean. If you were to adjust everything to the best setting, you could get to 48. The worst setting is really bad. And then on this graph, it shows you ASHRAE 90.1 and the zero tool numbers. So when you're above 90.1, this dial is red. When it gets below that, it turns orange. And when it's in the Architecture 2030 area, it turns green. So I'm going to quickly adjust several of these. The triangle is the setting coming from Revit. It actually calculated a bunch of a large range of values. So here's the 20% that we plugged in. This is the south wall. You can have analytical sunshades factored in without actually having to draw the sunshades like I did on the west side. Here's the glass, which is somewhere between double OE and triple OE. The slope of the graph actually indicates how much potential there is to save energy for that particular input. The glass setting again. The west side, obviously, if this graph is steeper because the long west side of the wall, if you have more window area, it's going to use more energy. That's what that graph was showing. Once we get into the internal loads, we'll start seeing some bigger changes with the EUI. Oops, I didn't mean to go there just yet. Let me finish this first. So here is basically the R38, the triangle is that setting I specified in Revit, but there's a bunch of other wall types listed there. So this goes all the way from uninsulated, which could be some existing building scenario, which is why it's an option. the air infiltration, so somewhere 0.4 was mentioned in the post, to something more aggressive. If you don't know what the setting is, you can leave it at a range, so that still kind of factors into the mean. There's never really a specific one EUI, even although technically if you have one input or one value for every input, that is a specific EUI. Plug load in watts per square foot. HVAC. So there's a ASHRAE package terminal heat pump to high efficiency heat pump. So somewhere in there. Operating schedule, of course, is a big one. So again, you could have it at a range if you're not totally sure. And now if we back out here and look at this again from a big picture, that 90.1 2010, using the various years reduction codes from CBEX, similar to what was mentioned for 2019, you could normalize that a little bit more. And then the interesting thing though is the EUI is still quite a bit higher than what was mentioned in the post, based on thermal zoning and really specific inputs. But from here we could try different shapes of buildings and number of floors and some other passive strategies to try and adjust this number. So I'm curious to hear what other people think of this process and continue the discussion. By the way, I don't think I mentioned this, but Insight currently uses DOE 2.2 in the future, and I'm part of some beta where it will use Energy Plus for basic systems like this. The results should generally be the same. I have a blog post I think I've mentioned before on the Lake Flato blog that compares this with Climate Studio's tool that uses Energy Plus, and I carefully matched all the inputs and everything was super close. But in the future, the Energy Plus one will also have a few more advanced HVAC systems, like a VRF with the DOES system to be able to choose from, which is really great.